Good day friends, welcome to my channel lecture series in power electronics. In this session, let us learn the very basics of a resistor. A resistor is a two-terminal electronic component and it implements electrical resistance in a circuit. The main purpose of a resistor is to limit the flow of electric current. It's a passive element. By passive, what it means is these components do not generate or amplify electrical signals. Rather, they only consume or store energy. In other words, components that do not require an external power supply to operate. Resistors, capacitors, and inductors are some examples of passive components. A resistor would look like this. There are a number of color bands in a resistor, and the size of the resistor also depends on the power it would carry. Just to visualize, a 1/8 watts resistor would look this small, whereas a 10 watts resistor would look this big. So depending on the requirement, we may get a resistor of the same value for different power ratings. There are two standards, ICE standard and ANSI standard, ANSI standard. Based on these standards, the resistors are represented in the electric circuit by different ways. As per the ICE standard, that is International Electrotechnical Commission standard, the resistor is represented like this. And it's a fixed value resistor. If the value of the resistor is variable, if it is a potentiometer, then there is an arrow pointing along with the resistor symbol as per the ICE standard. If as per the ANSI standard, that is the American National Standards Institute standard, the resistor is represented just like a box of a fixed value. If the value of the resistor is variable, then there is an arrow mark along with the box-like structure. Commonly used resistors have bands marked like this as shown here. The very commonly used resistors have three color bands and one golden or silver band at the end. The first band represents the first digit of the value. The second band represents the second digit, and the third band represents the number of zeros. And the fourth band, which is a gold or a silver band, represents the tolerance. This image tells us the value of the band colors. So if the band color is black, it represents a value 0. If it is brown, it is 1. If it is red, it is 2. Orange 3, yellow 4, green 5, blue 6, violet 7, 8, gray, 9, white. So from the darker shade to the lighter shade, the value of the color band increases from 0 to 9. Let us understand the color coding using a sample resistor. Now let us see that this resistor has got 3 red bands and 1 golden band. This means that the first band represents the first digit. Red being 2, the value for red is 2. The first digit is 2. The second band is also red. So the second digit is also 2. The third digit represents a number of zeros. And this third band represents there is 2 zeros. That is 2, 2, 0, 0 is the value of this resistor. And there is a golden band, which means it is 5% tolerance. That is from the value 2200 plus or minus 5%, that is 110 ohms. The value of the resistor could be 2310 ohms on the higher side or 2090 ohms on the lower side. Let us understand how to calculate the value of a resistor, generally a 4-band resistor. Here, in a 4-band resistor, there are 3 bands on one side of the resistor and 1 band at the extreme end. The first band represents the first digit. The second band represents the second digit. The third band represents the multiplier, or in simple terms, the number of zeros. And this tolerance represents the approximation in the value. If it is a golden band, then it means that the value of the resistor can be plus or minus 5% of the exact value. Suppose I have a 100 ohm resistor, then if I have a gold band, the value of the resistor can be either 95 ohms or 105 ohms. If it is a silver band resistor, it means that the tolerance is 10%. So a 100 ohm resistor can typically have a value 90 or 110 ohms. So let us see the examples here. In this first resistor, we have three bands, that is red, yellow and green. Then it is a silver band. So red represents 2, yellow represents 4, green represents 5, and the silver is 10% tolerance. So first band represents the first digit 2, the second band represents the second digit, that is 4, and the last band, the third band, represents the number of zeros or the multiplier. So it is 24 followed by 5 zeros, which means the value of the resistor is 2.4 mega ohm plus or minus 10%. The second example, we see that the bands are red, black and black followed by a gold band. So red means 2 first digit, black 0 second digit, third black number of zeros or the multiplier. So the value of the resistor is 20 ohms, band being gold for tolerance, it is plus or minus 5%. The third example, here we have three bands, green, blue and black followed by a silver band. So green means 5, blue means 6, black means 0 and silver is 10% tolerance. So 5, 6 followed by no zeros. So the value is 56 ohms plus or minus 10%. The next example is blue, violet and red. Blue means 6, violet is 7, red is 2. Again we have a silver band which is 10% tolerance. So 6, 7 followed by 2 zeros. The value is 6.7 kilo ohms plus or minus 10%. The next example, you have red, black and orange followed by a golden band. So red means 2, black means 0, orange means 3, gold is 5%. So 2, 0 followed by 3 zeros, that is 20 kilo ohms plus or minus 5%. So this is the way we can calculate the value of the resistor. The commonly used resistors are all of 4 bands. The general resistors used are all 4 band resistors only. There are 5 band resistors and 6 band resistors also. In the case of a 5 band resistor, the 4 digits and the tolerance band is there. So the first 3 represents the first digit, second digit and the third digit. The fourth band represents the multiplier and the fifth band represents the tolerance in the case of a 5 band resistor. In the case of a 6 band resistor, the 1, 2, 3 represents the 3 digits. Fourth is the multiplier, similar to the 5 band resistor. Fifth is the tolerance and sixth is the temperature coefficient. They are much rarely used. So commonly used resistors have 4 bands. Resistors find applications in most of the electronic circuits as well electrical circuits. They are mainly used to reduce the current flow, to adjust the signal levels if they are having a variable value, to divide the voltages, to bias active elements, and to terminate transmission lines. Let us see an example of a resistor being used in a circuit. There is a 15 volt supply and there is a LED which will work with only 3 volts. The supply is 15 volts. The required value of voltage is only 3 volts. The balance 12 volts should be dropped in a resistor. Only then the LED will work without any damage. To drop the 12 volts, we need to connect a resistor here. So if we connect, example, 600 ohms resistor, then the voltage drop across this resistor will be given by I into R. If there is a 20 milliampere current flowing through the circuit, the voltage drop in the circuit is I into R, that is 12 volts. In other words, to drop 12 volts, what is the value of resistor required can also be calculated in depth. But just to show an example that the required value of voltage for a particular application can be obtained by dropping the excess voltage in a resistor. In this session, we have learnt about the resistors, the basics of it, and how they are used in electronic circuits. Up next, we'll see how the resistors behave when they are connected in series or parallel. Thank you. Electronics. Let us see how resistors are connected in series in this particular session. In this case, we see that the resistors are connected in series. R1, R2 and so on up to Rn are connected in series. They are said to be connected in series because one end of R1 is connected to one end of R2. The next end of R2 is connected to some other resistor. There is just one connection between R1 and R2. There are certain conditions using which we can say that the resistors are connected in series or not. The conditions are that only one end of each resistor is connected to one end of the other resistor, and there should not be any branching here. You can see here the resistors R1, a 10 ohms and a 20 ohms resistor are connected in series, and this 20 ohm and 30 ohm resistors are connected in series. They are called as a series connection because at the junction there is no branching at all. And in a series connection, the current flow will be the same throughout. Say for example, a 5 ampere current is flowing through this resistor of 10 ohms. Same 5 ampere will flow through the resistor of this 20 ohms. 5 ampere will flow through the resistor of 30 ohms. So the voltage, though it is different, the current in a series connection will remain the same. The voltage will be different across each resistor based on the value of the resistor. Suppose the resistor value is lesser, that will be lesser voltage drop. If the resistor value is more, that will be more voltage drop. In this particular case, the voltage drop across the 10 ohm resistor will be lesser compared to the voltage drop across the 30 ohm resistor. Let us see how the resistors are connected in this picture. Here we see that there are a number of resistors connected. We say that this 10 ohm resistor and the 2 ohm resistors are connected in series because there is a junction which is formed between these two resistors contain no branching. Whereas we cannot say that this 4 ohms and 10 ohms are connected in series because at the junction there are different connections going. So here again this 2 ohms and 8 ohms are not connected in series. This 8 ohms and 4 ohms are not connected in series because at every junction we see that there is branching. So two resistors are said to be connected in series only if only one end of each resistor is connected to the other end of second resistor. If we have a number of resistors, say R1, R2, R3, R4 and so on, connected in series, to find the equivalent resistance value, the formula used is R equivalent is equal to R1 plus R2 and so on up to Rn. So the equivalent value is the sum of the value of the resistors. The voltage drop across each resistor is given by the product of the current and that particular value of resistance. For example, the voltage drop across R1 will be the current I into R1. The voltage drop across R2 will be the current I into R2. The voltage drop across R3 will be I into R3 and so on. So the voltage drop across each resistor is the product of the current and that particular value of resistance. The power consumed by each resistor is given by I square R, the current square into the value of that particular resistor, or the voltage drop across the resistor squared divided by the value of R. Let us understand as to how to calculate the equivalent resistance of the resistors when they are connected in series. the current in the circuit and voltage across each resistor using this simple circuit. Here we see two resistors 4 ohms and 6 ohms connected in series and a voltage of 24 volt is applied. So now first point is to calculate the equivalent resistance in the circuit. So when resistors are connected in series, the equivalent resistance is the sum of the values of the two resistors. So here we see 4 ohms and 6 ohms connected in series. Equivalent resistance will be 4 plus 6, that is 10 ohms. And now let us know what is the current flowing through the circuit. The current flowing through the circuit I is given by V by R as per the Ohm's law. The voltage here is 24 volts. The equivalent resistance is 10. So the current in the circuit is V by R, which is 24 by 10, which is 2.4 ampere. Now we know the equivalent resistance as 10 ohms. The current in the circuit is 2.4 amperes. To know the voltage drop across each resistor, the voltage drop across the resistor 4 ohms is calculated using the formula I into R1, where the current is 2.4 ampere, value of the resistor is 4. So the voltage drop across the resistor of value 4 ohms is 9.6 volts, and the voltage drop across the resistor of value 6 ohms is 2.4 into 6, which is 14.4 ohms. So if we add these two, we get the value of 24 volts. The entire voltage is dropped across these two resistors which are connected in series in the proportion of their value of the resistors. Here we can understand that a resistor with a lesser resistance value has a lesser voltage drop across it. That is 4 ohms resistor has only 9.6 volts dropping across it, and the 6 ohms resistor, which is higher than 4 ohms, is dropping a voltage of 14.4 volts across it. Thank you. Up next is resistors in parallel.